Yes, grade 12, welcome back. So now we're looking at question 3, okay? Question 3, as you can see, this one is also a question on patterns, sequence, and series, right? So that is what is happening there. So let me insert a page first. There you go. So question 3, okay? It's a question on what? Patterns, sequence, and series, okay? That's where you that's what they're testing in that question. Whatever that you will be answering, it is going to be coming from what you have learned in patterns, sequence, and series, right? So let's see what is it that they gave us. Now 3.1, they are saying prove that the sum to infinity, there is the infinity thing on top there, the sum to infinity, right? 4.3, the sum to infinity, and this thing here, you see, it's a geometric thing. The sum to infinity, obvious. When we talk about sum to infinity, it's the geometric thing. So that's the pattern that defines it there. 4 multiplied by 3 exponent 2 minus k is a convergent series, right? Show all your working, right? So let me write the summation first on my answer sheet. This is my answer sheet, right? So this is the is equal to 1, and then on top there it's a that's some infinity thing, sum to infinity. See, that's what I'm saying, sum to infinity. And what is it that you have? 4 multiplied by 3, okay? 4 multiplied by 3 exponent 2 minus k. Exponent 2 minus k, right? So they're saying you're supposed to prove that this thing here is convergent, right? So one thing that you must do is you have to first find the series, okay, or the sequence, okay. So let me check what is that they said here. What is that they say? Yeah, it's a series. So you have to find the series first for you to be able to talk about it being convergent or not being convergent, right? So series is not a sequence. This one is a series. So let's find the terms in the series, right? So how do you find the first term? Like you see, this one is infinite, so it starts with 1 there. So bottom minus, so it's not going to give us anything. Top minus bottom is not going to give us the number of patterns. So it's fine. We just going with what we have there. It's sum to infinity. So if I take this thing here, remember, it represents the formula. Tn is equals to 4 multiplied by, it's not n, it's k in fact, but then 4 multiplied by 3, 2 minus k, right? So I'm going to start substituting with k equal to 1, and I get my first pattern in that one, and then I'll get my ratio, right? And then I check if my ratio is convergent or it is not convergent. So 4 multiplied by 3 exponent 2 minus, with k being 1, I get a 12, okay? And then what comes after it? K is now 2. I get a 4, right? And then with k being 3, I get 4 over 3. And then with k being 4, I get a 4 over 9, right? So you can continue. But then remember, this thing here, it's infinity. It tells you that there are many terms that follows after this, right? So you must just remember that. So what is R here? R is going to be 4 divided by 12, right? And then 4 divided by 12, this is what? This is 1 over 3. You see, the answers that you need, you are having them already, okay? So you have them. So what is it that you know about convergence? If you forgot, you can find this on your formula sheet. Let me just remind you to the formula sheet, okay? Because like with exam, you have to know everything. You don't know what is it that they're going to tell those people, but you have to know everything and use everything that you know so that you'll be able to solve the questions. So for convergence, this is what it follows here. For convergence, as you can see on the sum to infinity formula there, R must be less than 1, but greater than -1, right? Okay, so this is what you know. So convergence for convergence, right? Must be less than 1, but greater than -1, right? That's where our R should be. So looking at the R that you got, this one here, 1/3. 1 divided by 3, this is what? 0.33, right? It is less than 1, it is greater than 1, right? So that alone prove that. So what are you going to say? So I'm just going to say, since equal to negative what? Since R equal to 1/3, is what? Is within follows what? Let me just, I'm trying to use the English. It doesn't matter how I going to follows the condition. That's the condition that you're given, right? Let me insert a page here. Since it follows the condition, since it follows the condition, R being greater than 1 and R being greater than 1 and R being greater than 1. What does that mean? It means the series converges. Okay, the series converges. So what is it that we need? So that is it. You've answered the question. The way in which you put your English, it doesn't matter in maths. You see, it doesn't matter in maths. The way in which you put your English, it doesn't matter. So you saw that your R, which has 1/3 here, it's within this. It follows that condition. So the way in which you put your English, it doesn't matter. Now, what is it that they want us to do next? Let's see. What is that they were testing us next? Okay, let's see. What is it that they were testing us? So let me just go back quick. Let me just go back quick. Okay, there you go. So here, what are they saying? They are saying 3.2. If that whole sum, right? If that whole sum, there it is. The whole of the sum is equal to 2/9. You see, and they gave us K is equals to P there. Okay. So let me just write that on my answer sheet so that you see what is it that they are doing, those people. See. I've went very far. It was supposed to not go far. Okay, so they are giving us the very same sum. This is 3.1, 3.2, right? They are giving us the very sum, okay? The very sum. So they're saying here K is equals to P, right? And then the sum to infinity thing there. And then 4 multiplied by 3 exponent 2 minus K. And they're saying the whole sum is equals to what? It is equals to 2/9. Yes, it is equals to 2/9. And then they want us to determine the value of P there, okay? They want us to determine the value of P there. So how are you going to go about determining the value of P? So remember, what is it that is happening here? As we have seen, as we have seen, right? With the previous one, as we have seen with the previous one, like this thing here, we said what? This thing here is the sum to infinity, right? So the sum to infinity, like the first thing that you're supposed to do, like what we did in the previous one, was to evaluate our series, right? To evaluate our series. So where is it going to start? Our series, we're gonna have like we substitute everything, right? We're gonna have like what is the very first value of P? The very first value of K here, it's P, right? So we're gonna have 4 multiplied by 3 exponent 2 minus P, right? This is the very first value of P, right? And then it will increase. You're going to have those other ones. So you see, like it's in terms of alphabet here. You see, let me put it this way. Okay, we're gonna have 4 multiplied by 3 exponent 2 minus P plus 1. In that order, and that whole sum, this sum, the whole of this sum, I put it into infinity. And the fact that it's something that you're saying it's sum to infinity, the sum to infinity formula has to work somewhere here, okay? And that is equal to 2/3, okay? So what is sum to infinity? We've already seen the R for this thing, right? We've already seen the R for this thing to say R is equal to 1/3, okay? This is the question that is being brought up on that pattern. So we have seen that R is equal to 1/3. Hence, we don't have to like find out that is R again. But then what is sum to infinity? Sum to infinity formula says what? We're going to go back to our formula sheet. If you've forgotten, let's just remind you, you don't have to even remember this. This thing is there in the exam. You're going to find it. You don't have to stress yourself, crack your head by trying to remember the sum to infinity form. It is there on the on the information sheet. So sum to infinity, there it is, a over 1 minus r, right? So let's just take it like that. This is a over 1 minus r, right? Now, I said to you, this is sum to infinity. Why is this thing sum to infinity? There is an infinity thing on top there, this infinity thing. So it means the whole of this sum that you're given here is the sum to infinity, which is equals to 2 over 9, right? It is equals to 2 over 9, right? And then the fact that the sum to infinity for this question is equal to 2 over 9, let me say the page. Let me say the page. There we go. So it is 2 over 9, as you can see there. Okay. Then what is a? Like as we were extending the series into 2 minus p, right? So you saw what. So this is my term in terms of p, right? Term number 1 in terms of p. So that is what we want. It is equals to 2 over 9. So we're going to say what? Then a, which is 4 multiplied by 3 multiplied by 3 exponent 2 minus p, right? That's my 8 there on top. Over 1 minus r. What is, you don't have to work it out again, okay? And then this is equals to 2 over 9. Now we're ready to solve for p. So let's solve for p. What am I going to do? I'm going to say, you see, this 4, right, divided by this. That's what I'm going to say. So 4 divided by 1 minus 1 over 3. What am I getting? I'm getting 6. So I have 6 multiplied by 3 exponent 2 minus p. And this is equals to 2 over 9. Okay? That is what I have with me. Now, 3 exponent 2 minus p is equals to 2 over 9. Okay? I'm taking out the 6, 2 over 9 divided by 6. What am I going to get? I'm going to get 1 over 27, right? So you see, this is 3 exponent something. So it means what? I'm going to have 3 exponent 2 minus p is equals to 27. I'll write it as what? 1 over 27. You can be written as 3 in terms of 3. So 27 is equal to shift fact 3 exponent 3. 1 over 3 exponent 3, right? Now, if I bring it on top, okay, this is 1 here. If I bring it on top, 2 minus p, you know, any number to the exponent 0, it's 1. So if I take 3 exponent 0, 3 exponent 3. So if this one is 1, I can write it in terms of 3 to say 3 exponent 0 is equals to 1, right? And then I'm taking this 3 here. Very important, the same base, you take one base and subtract the exponent. So 3 exponent 2 minus p is equals to 3 exponent 0 minus 3, okay? Now, with us having this, I'm having 3 here, 2 minus p is equals to, then 0 minus 3, that is 3 exponent negative 3, right? Now, this is an exponential equation. Exponential equation, if the bases are the same, then we create exponents. Let me insert a page. I'm going to my page, as you can see. So we have seen that the bases are the same, right? And then you're supposed to equate the exponents. So 2 minus p is equals to negative 3, right? What does that mean? Now 2, I take the 3 across, and I have 3 here is equals to p is equals to 5. And in that way, you have solved for p. So just be careful and make sure you're not making mistakes. And let's see. What is it that comes after this question? We're still in question number 3. Let's see what comes after that question. Wow, we are done with question number 3. You see? So exam, they are examining what you learned, okay? And you don't know what is it that the examiner is going to examine, but now you have an idea as to what is it that you're supposed to prepare yourself for, okay? By answering past exam paper. So that is it with question 3. I will meet when we do question 4. Bye for now.